Hello all, this is Asiba. Welcome to today's session on ninth lab program, which is to develop a menu-driven program to fill the polygon using ScanLine algorithm. Right, so we have already discussed what do we mean by a ScanLine algorithm. So a ScanLine algorithm basically is used to scan the lines, right, and it will try to find out which are the intersecting pixels or which are the intersecting scan lines between the intersecting edges, right? So and we are trying to fill the color into the polygon. So scanline fill algorithm, it intersects scan lines with the polygon edges. So which are the scan lines which are within the polygon and which are outside the polygon? Those scan lines which are outside the polygon will be clipped, right? And those scan lines which are inside the polygon, only those pixels will be filled by color. So fill between the pairs of intersections of the edges. So the basic design of this particular polygon is we are trying to fill the polygon from top to bottom, so from bottom to top and from left to right. Always you have to remember we are trying to fill the polygon from bottom to top and from left to right. That is why we say for y is equal to y minimum to y maximum, right? So we are traversing the polygon from the bottom to the top. So y min to y max. So we are trying to find the scan lines, right? So which intersect with each edge, right? So first try to find those scan lines which are there inside the intersection, then sort those intersection by increasing x-axis, right? So we know that y is from y min to y max, right? So we have to find the intersection with respect to x-axis, right? So because we can see here x-axis is decreasing, right? But if I take this right side edge here, x-axis will be increasing, right? So we have to find the intersection points of the scan lines by with respect to the x-axis, right? So by increasing x-axis, right? So then we have to fill pairwise between 0 to 1, 2 to 3, like that, right? So x0 to x1, x1 to x2, like that. We have to try to fill the pixels which are within this particular, which are within this intersecting edges, right? So those scan lines which are in between the intersecting edges, find the intersection, right? So, and then try to sort those intersection in increasing x-axis, right? So here if I take, it is increasing x, here it is decreasing x, right? So find the intersections, then afterwards we have to try to fill those pixels which are inside the polygon. So that is why we write it as fill pairwise. So let us take an example in order to clearly understand what is a scanline fill algorithm, right? So in this example, right, so you can see here we have a polygon. So the polygon has 4 points here. I have taken P1, it is 5, 10, P2, it is 20, 15, X is 20, Y is 15, right? So P3 is 15, 25, right? So X is 15, Y is 25, right? And P4 is 0, 20, right? So X is 0, that is why the point is on Y axis, and it is Y is 20, right? So like this, we are taking X axis, Y axis. This is Y is 15, this is Y is 20, right? So that is why I'll get a polygon like this. So once you have the polygon of this shape, right? So what we are doing is we are trying to find the lines of the polygon, right? So we'll, because we have the scanline algorithm, right? So which it first tries to find which are the intersecting edges, and it will try to fill the polygon which is the inner part of the polygon, right? So that is why I know that first line is what? First line is P1 to P2, right? So line 1 is from the points P1 to P2. So what are the y coordinates of this particular line? It is 10 to 15. So you can see that it is going from y min to y max. Always we have to remember that we are trying to fill the polygon from bottom to top and from left to right, right? So y min to y max. So I need not swap the values. I'll keep it as it is. What is the left edge of 10? The left edge of 10 is 5, right? And the right edge of point is 20, right? So between 5 to 20. So left and right. So left and right of this, from 10 to 15, I have to go and I have to fill the color of the polygon from 5 to 20. That is from left edge 5 to right end point, left end point 5 to right end point 20. Then come to the line L2, which is formed by using the points P2 and P3. If I take this particular line, right, so I have my y min and y max as 15 and 25, right? So y min to y max, so 15, 25. So I need not swap the values, right? So what I will do, I will see the left end point and right end point. Left end point is 20, right end point is 15. That means from 20 from the x-axis to 15 to the 15 of the x-axis, right? So we have to fill, right? So 20 to 15, we have to try to color the polygon. Then coming to the next line, which is P3 to P4. So P3 to P4, I have my y min as 20, y max as y min as 25, y max as 20, right? So because I'm coming from P3 to P4, so 25 to 20, right? But I cannot fill from 25 to 20 because always we have the condition that y min should be lesser and y max should be higher, right? So therefore we have to swap the values. So I'll swap the values. I will get it as 20 and 25. Right, so once I swap these two values, I have to swap the corresponding, so I will swap these two values, right? So that means I'll move from P4 to P3. So left end point is 0 and right end point is 15. So 0 to 15, from 20 to 25, I'll be filling the color. Then the last line is from P4 to P1, right? So here also I'm moving from bottom to I'm moving from top to bottom, so I need to swap the points, right? So I will swap the values. So if I swap the y values, then I have to swap the x values also, right? So because 5, 10 and 0, 20. So swap the values. That means I have to start from 5, 10 to 0, 20, right? So I'll be getting it as a 10 and 20, right? So once I get 10 and 20, what is the left end point? Left point is 5, right end point is 0. So I have to go from 5 to 0, right? So like this, we have to find out our y min, y max, and what is the left end point and right end point which we have to traverse. Coming to the program, right? So the first line of your program is hash include windows.h, right? So hash include glut.h, hash include stdio.h. Why I'm using windows.h header file here is because we have to create a menu driven program. Menu driven program in the sense, in our program, right? I'll just show you the output of the program. So in our program, since it is a menu driven program, first we should have a menu, right? So in the menu, I'm having three options: clear, draw, and quit. Clear is to clear my screen, right? So draw, inside this draw, I'm creating one more sub menu. The sub menu has a scan fill polygon. That means if the moment I click this particular polygon, scan fill polygon, right, my entire polygon will be colored with whatever color I have chosen, right? So next we have quit. Quit means it will come out of the, it will quit. That means it will close the output, right? So in order to have this, this is a menu driven program with three options: clear, draw, and quit. And inside the draw, I have one more sub menu, which is scan fill polygon, right? So to do this particular task, I'm using the, since we need window ID, submenu ID, so I am making use of hash include windows.h, right? So then coming to the variables, we need few static variables, right? So you know what do we mean by static variables? Their value will not change, right? So till the execution of the program, their value will not change. So static int window, static int menu ID, right? So this is for generating the menu. Then static int submenu ID, because inside my main menu, I have one more sub menu for scan fill polygon, right? So then static int value is equal to 0. One more variable I'm taking, which is value, right? So next I'm drawing a polygon which has my x1, y1 as 200, 200. You can see that I have plotted the polygon here, x1, y1 with 200, 200. x2 is 100. 100 means it will come towards the left hand side of 200, right? So x2 is 100, y2 is 300, right? So that is why I've taken the point above. Y is increasing, so x2 is 100, y2 is 300. The third point is x3, y3. X3, y3 is, x3 is 200, so it will come same place as x1. X3 is 200, whereas y3 is 400. 400 means little above 300, so I have taken it as x3 is equal to 200, y3 is equal to 400. And we have the last point, which is x4. X4 is 300. 300 means towards the right of x1, so x4 is 300 and y4 is also 300, right? So this is how we will get our polygon for the points, right? So x1, y1, x2, y2, x3, y3, x4, y4, right? So you have to change these coordinates and you have to check different types of polygons, like concave polygon, convex polygon, all those things, right? So coming to the functions, right? So the first function what we have here is a draw pixel, right? So this is basically used to color the pixels, right? So from x to y, right? So void draw pixel, it is basically used to filling the points with a delay, right? So delay is nothing but we are trying to fill the polygon line by line, right? So like this, we are trying to fill the polygon line by line. If I want to if you don't give delay, right, so what happens is immediately as soon as you execute the program, you can see the output that the entire polygon is filled with red color, right? But I want to see slowly line by line how that polygon fills, how the color is filled inside the polygon, right? So that's why in order to have that realistic view, I'm giving some delay here, right? So filling points with the delay is the function. GL color 3F 1.0, 0.0, 0.0. That means I'm selecting red color. So red color 1.0, 0.0, 0.0. So I have selected red color, sleep of 50, right? So this is a function which is used to give the delay, right? So if you give lesser delay, then you can see that it goes faster, it fills the polygon faster. If you want to see, if you want to fill the polygon very slowly, you have to increase your delay, right? So sleep of 50, this is basically used to set the delay time. Next, GL begin, GL underscore points. So GL begin is the function, right? So how I'm filling my polygon, I'm filling my polygon pixel by pixel. You have to remember that we are trying to find the intersecting edges in this particular program, and once we find the intersecting edges, what we are doing, from the left intersection to the right intersection, we are trying to fill the polygon pixel by pixel, right? That is, every pixel is nothing but points. So that is why I'm taking GL begin of GL underscore points, GL vertex of x comma y. That means from x to y, I will try to fill the polygon, right? So every pixel will have x and y coordinates. So I'm taking GL vertex to y of x comma y. GL end and GL flush. GL flush is used to force the execution of OpenGL functions, right? So like this, in my draw pixel function, what I'm doing, I'm trying to find out the points on the scan line, right? So on this particular scan line, I will try to find out the points, and I am trying to color those points pixel by pixel which has x comma y coordinate. I'm trying to fill the polygon with what color? I'm trying to fill the polygon with red color. That is the color what you have, what we have chosen in this particular program. If you want to change the color, you can change it here. Next, coming to the next function. So the next function is to detect the edge, right? So for edge detection, we want, right? So we have the polygon here, right? So the polygon moves from left edge to right edge, right? So we have to detect the intersection points, right? So that is why I'm taking one function which is called as edge detect. Edge detect x1 y1 x2 y2, right? So from the first point, that is x1 y1 point, right, to the next point x2 y2, I have to detect the edge, right? So and I have to detect my left end point and right end point, right? So as we have seen in this example, right, so I will find out the points, that is x1 y1 x2 y2. I will check whether it is going from y min to y max, right? So then I will find out which is the left end point and which is the right end point. So in all these operations are done by using the function which is called as the edge detect function, right? So here I'm taking one variable which is mx, that is basically used to calculate my x value, then x temp and integer value which is I. This is my looping variable, right? So first I will check if y2 minus y1 is less than 0. That means if y2 is less than y1, right? Always I have to go from y1 to y2. So when I'm going from y1 to y2, what I want my y2 should be greater, because I am going from down to top, right? So this is how we will be going, right? So y1 should be smaller, y2 should be greater, larger, right? So then there is no need to swap. If y1 is less than y2, no need to swap. If at all y2 is less than y1, right? So in this case, if you take y2 is less than y1, then I have to swap, right? So if y2 is less than y1, that is why I'm taking y2 minus y1 is less than 0, right? So if y2 is less than y1, then, right, so take this example, y2 is less than y1 means 20, y2 minus y1 is less than 0 means 20 minus 25. If you do 20 minus 25, you will get it as minus 5. Minus 5 is less than 0, right? So if you get any number which is less than 0, that means y2 is less than y1, right? So if y2 is less than y1, what I have to do, I have to swap the y values, right? So if I swap the y values, the corresponding x values will also change, right? So if 10 goes here, 20 comes here, the corresponding 5 also should go, right? So 5 comma 10, 12, 0 comma 20, it should become, right? So that is why what I'm doing, I'm swapping the y values. Similarly, I'm swapping the x values, because I have to swap the entire point if y2 is less than y1, right? So next we are checking, we are swapping. If at all y2 minus y1 is not equal to 0, that means y2 is not equal to y1, right? So if y2 is not equal to y1, then if y2 is not equal to, if y2 is not equal to y1 means what? That means that I am moving from y min, both are different points. That means I have to go from bottom to top, right? So if y2 minus y1 is not equal to 0, that is y2 is not equal to y1, what I'm doing, I'm finding out some value, right? So this is nothing but my intersecting point value. I'm trying to find out mx is equal to x2 minus x1 divided by y2 minus y1, right? So this is basically used to find out the difference values, right? So what I will do, mx will be equal to x2 minus x1, right? So if I take this point x1 y1 and x2 y2, right? So here I will check y1 and y2. So y1 y2 is not equal to y1, right? So y2 is not equal to y1. So what I will do, x2 minus x1. So x2 minus x1 is nothing but at 100 minus 200, right? So x2 minus x1 is 100 minus 200. So 100 minus 200 divided by y2 minus y1. 100 minus 200 divided by y2 minus y1, which is 300 minus 200. So 100 minus 200, I will get it as minus 100. 300 minus 200, I will get it as 100. So 100 minus 100 divided by 100, I will get it as minus 1, right? So minus 1 means that at the next point, so what will be this point? So since if this is 200, the next point on the scan line, this will be, it has to be reduced, right? So this will become 199. So every time I have to reduce a minus 1, minus 1, minus 1, right? So that I will reach from 200 to 100, right? So to do that calculation, we are taking mx value. This is not the slope, it is one incrementing variable, right? Just to find out the value of x, right? So by intersection point on x. So mx will be equal to x2 minus x1 divided by y2 minus y1, which we got it as minus 1, right? So else we are just taking x2 minus x1, because if y1 is equal to y2, right? So if y1 is equal to y2, if I take this case from 300 to 300, right? So here y1 is equal to y2. If at all I have a point where y1 and y2, in this polygon we are not having y1 is equal to y2. So if at all I have a point where y1 is equal to y2, then I need to take care of only x, right? So I will just calculate x2 minus x1, right? So then I'll make the next point to become the current point. That means for this value, what I got, we got it as mx is equal to minus 1, right? So the next point, from the current point to 200, I have to find the next intersection point, which is 198, right? So I will make the x variable as equal to x1, right? So what is the my value of x1 here? X1 is equal to 200, so x is equal to 200 now, right? So x is equal to 200. Now I will take for y value, right? For I is equal to y1, I is less than or equal to y2, right? So you have to always fill the polygon from bottom to top. I is equal to y1, I is less than or equal to y2, I plus plus. I will check if x is less than left end of I, right? So x value is what? X value is 200, right? So if x is less than 200 is less than 200, right? So I will check this, right? So 200 is less than 200, no, right? So what I will do, if at all it is lesser, if x is less than 200, if x value whichever we have, right? So if it is less than the left edge is your 200 and right end point is 100, right? So you have to fill from 200 to 100, right? So if at all it is less than, then that will become the left edge. If at all it is greater than, if x is greater than the right end point, then it will become the right end point, right? So is 200 greater than 100? Yes, it is greater than 100, right? So right end point is also 200 now. That means I have to start from 200 comma 200. I have found out my first left end point and right end point, which is 200 comma 200. Then x value will be equal to what? X plus is equal to mx. That means 200 minus mx value, we got it as minus 1. So 200 minus 1 means 199. So next time again I will repeat this loop, right? So I have to repeat this loop from 200 to 300, right? So next intersection point will be what? Next intersection point will be, I will decrement the x value and I have to increment the y value, right? So I will decrement the x value. So I will get it as x is x1 will be equal to, x will be equal to 199. So 199 comma 201. Next point will be 198 comma 202. 190 7 comma 203, like that I will go on until from 200 to I will go back to 100. So and I will come to 300. So I am decrementing x value and I am incrementing y value, right? So this is to find the left end point, right end point of the scan line, right? So like this we will be using our edge detector problem in order to detect every scan line edges, right? So next we have the scan fill function. So under this scan fill function, again I have to fill, right? So I'm taking 4 four variables x1 y1, x2 y2, x3 y3, and x4 y4, right? So because I have to fill the entire polygon which has minimum 4 points, right? So a polygon basically will have 4 points, right? So if you are in this case, we have considered a polygon with 4 points. That is why I'm taking it as x1 y1, x2 y2, x3 y3, x4 y4. So if at all you want to change the polygon, right? So you for 3 points, then you can have x1 y1, x2 y2, x3 y3, right? So then you will get it as a triangle. So here we have taken a rhombus as an example, right? So I'm taking the left end point as 500, right end point as 500, right? So because I'm setting my GLU ortho 2D as 0 to 500 and 0 to 500. So this is the maximum value. You can take any value, 500, 700, 800, whatever value, 600, whatever value you want, you can take, right? So for I is equal to 0, I less than 500, I plus plus. So left end point, I'm taking it as 500 and right end point, I'm taking it as 0, right? So initially, these are the values of my left and right. Then I'm calling my edge detect function. So edge detect for, we have to detect the edge from x1 y1 to x2 y2 with the LE and RE coordinates, right? So then again edge detect from x2 y2 to x3 y3 LE comma RE. Again edge detect from x3 y3 to x4 y4, again with the left end point and right end point. Again edge detect from x4 y4 to x1 y1 with LE and RE, right? So like that, for between every pair of edges I have to detect my intersecting points, right? So that is why this scanfill algorithm in turn calls your edge detect scanfill function in turn calls your edge detect function, right? So then we have for y equal to 0, y less than 500, y plus plus, right? So always we have to fill from bottom to top, right? So that is why we are going from 0 to 500, right? So if left edge of y is less than or equal to right end point of y, right? So what I will do for I equal to left end till I is less than right and I plus plus, I will draw the pixel from I comma y. That means I am trying to call the function from left to right, right? So and I'm trying to fill the pixel from left end point to right end point, right? So this is how we do it, and this particular function will call your draw pixel function. So in the draw pixel function, what we have the color, which color we want to fill, right? So and we have the x and y coordinate values which are supplied by this draw pixel of I comma y. Whatever is the value of I will be your x value and y value will be whatever value you are taking here. That means every time I am trying to fill the polygon from the left to right, right? So the next function what we have is menu function, right? So this menu function is basically used to create your drop down menu, which in turn has a submenu. You are trying to create a menu driven program, so I'm writing one function which is called as menu, right? So if num is equal to 0, so in the menu I have these three these three I have clear, right? So in my menu I have my clear in order to clear the polygon, right? So in order to draw the polygon, I have my draw button and I have my quit button in order to come out of the program, right? So if at all number is equal to 0, you can see here for quit we have taken the menu entry as 0. So if at all number is equal to 0, then what I will do, I will destroy the window. Destroy the window means I have to close the window and I have to come out of the program. Else whatever value is equal to num, right? So else value will be, value is one more variable what we are using. Whatever num value you will get, right? So num value is nothing but for clear button you are taking the value as 1. For a draw button you are taking the value as your submenu ID, which is 2, right? So for quit it is 0. I repeat, for quit it is 0, right? So based on this 0 value I'll be calling the destroy window. For clear it is equal to 1, right? So if at all it is equal to 1, that means that is the value of your clear, right? So if at all it is a draw, then it is a 2, because I'm having a submenu inside my draw, which is my scan fill polygon, right? So glut post redisplay, because every time you execute the program you want your menu to be displayed. That is why I'm using a function which is glut post redisplay. Then I have my create menu function, right? So submenu ID is equal to glut create menu of menu, right? So this will call my menu function, right? So from this menu function I will create the menu, right? So glut add menu entry. So I'm adding the menu entry now. For scan fill polygon, I'm taking the menu entry as 2, right? So this is a function which is basically used to add the menu entries, right? So then again menu ID is one more ID which will be created for my menu, right? So glut create a menu of menu. Whenever I'm creating any menu, by default this particular, by default this by default in your OpenGL, every menu will have a menu ID, right? So that is why we have declared it as a static menu ID, right? So the which will not change, right? So this variable we have already declared here as a static int menu ID, right? So static int menu ID. So static int menu ID. So I am getting my menu ID. So which is the return value of the function glut create menu. Then I'm adding the menu entry for clear button as 1, right? So then glut add sub menu, right? So why we need sub menu function? Because under my draw I have my sub menu which is scan fill, right? So that is why I'm adding glut add sub menu draw comma sub menu ID, right? So then I'm adding one more which is glut add menu entry for quit, right? So for quit I'm making use of the value as a 0. So glut add menu entry quit comma 0. Then since I have to attach this menu, right? So the moment you click the right button, then you will get your menu, right? So first you will get your screen, which is your black screen. You have to click some mouse activity should be there so that your menu is created on the screen, right? So that is why I'm adding the glut attach menu, which is glut underscore right underscore button, right? So for the right button of your mouse you are adding this particular menu, right? So this is how menu function works, which in turn calls your menu, right? So what this menu function will do, if at all the value is 0, so value of 0 means value is quit, right? So then you are destroying the window, right? So else whatever value you are getting for your menu, that particular num value will be assigned to the variable which is value, right? So glut post redisplay, because every time I execute the program I want my menu to be displayed, right? So next, coming to the display function. So in display function, first what we are doing, we are trying to clear our buffer, right? So gl clear gl underscore color underscore buffer underscore bit, right? So I'll be clearing my buffer if value is equal to 1. If value is equal to 1 means that means it is clear value. So what I will do, glut post redisplay, that means I will clear my buffers and once again I will come back. If at all value is equal to 2, so value is equal to 2 means I have to draw my polygon, right? So if at all value is equal to 2, then clear buffer, right? So initially I'm clearing the buffer, then I'm selecting my color, right? So color of my polygon here I have taken as blue color, right? So blue is the outline what I'm taking. So gl color 3f001.0, right? So blue color polygon, inside that you will be getting the red color which is filled, right? So gl begin gl underscore line underscore loop, right? So I'm using one function which is line loop. I'm not using polygon function here, right? Because if I use the polygon function, already it will fill the color into the polygon and it will give me the output, right? So but here I have to make use of ScanLine algorithm in order to fill the polygon. That is why I'm taking gl underscore line underscore loop, right? So what it will do, it will create a loop of the polygon, right? So I will give my variables gl vertex to x1 y1. From x1 y1 a line will be drawn to x2 y2. From x2 y2 it will be drawn to x3 y3. From x3 y3 to x4 y4, and by default x4 y4 will be joined to x1 y1, because here I have taken it as gl underscore line underscore loop. If at all you change this as gl underscore lines means one more you have to give, which is gl vertex to f of x1 y1, right? So otherwise your polygon will not be a closed figure, it will become open polygon, right? So that is why in order to connect all the points I'm making use of gl underscore line underscore loop, right? So then I am in this function, display function is calling your function which is called as scan fill, right? So scan fill this entire polygon, how many points are there in the polygon, x1 y1, x2 y2, x3 y3 and x4 y4. That is why scan fill of x1 y1, x2 y2, x3 y3, x4 y4, right? So gl flush, it forces the activation of OpenGL functions, right? So this function, display function, is calling my scan fill function, right? So scan fill function will in turn call the edge detect function, right? So in order to detect the intersecting edges, right? So again scan fill function is also calling my draw pixel, right? So display function is calling scan fill will call my edge detect to detect the intersecting edges. Once you have found the intersecting edges, then you are calling the draw pixel in the scan line in order to color the pixel, right? So next you have next function is initialization function, right? So for initialization we are taking clear color, right? So I'm setting my background color to be white, right? So when I see the output I will get a white color background. So in order to have the background white, I will take it as 1.0 1.0 1.0 1.0. When all are 1, you will get it as a white color. Then gl color 3f, you are selecting red color in order to fill your polygon with red color, right? So gl matrix mode, gl underscore projection, right? So gl load identity, right? So because because every transformation in your OpenGL is what it is, matrix multiplication, right? So that is why I have to make use of for orthogonal projection. What I'm doing, GL matrix mode, GL underscore projection, GL load the identity matrix, then I will call my ortho 2D, GLU ortho 2D. You can take it as 0 to 500, 0 to 500, right? So whatever value you take, so that much place will be reserved for your orthogonal projection. Then lastly, we have our main function. So inside the main function, first what I am doing, glut initialization, argc comma argv, right? So argc is the argument counter, argv is the argument vector. Glut init display mode, first I am setting my display mode. So this is RGB A because it is alpha, right? So RGB color, then glut underscore single. Glut init window size. So window size I'm taking it as 500 and 500. This is my window size, right? So glut init window position 100 comma 100. That means from the main screen, this particular window will be positioned at 100 and 100 from the main screen, right? So this is your thing. Then you are trying to position that polygon. If you don't give window position, your polygon will be on the top left corner, right? So from the top left corner, you want your window size, which is position 500 to 500. You want your window to be displayed at 100 comma 100, right? So the window which will be on the top left screen will come to the middle of the screen, 100 comma 100. Then you are calling window glut create window of menu driven programming for scan filling, right? So that is the name of your window. So every window will have a window ID. So that window ID will be copied to your window variable, right? So why we want this window ID? Because if at all I click on quit, I have to destroy my window, right? So destroy my window based on my window ID. So that is why I'm collecting the window ID here, right? So window will be ID will be equal to glut create window for menu driven programming for scan filling. Then you'll call your create menu function. So what create menu function will do? So create menu function will create a menu for you, right? So it will add the 3 buttons for your menu. It has clear, draw and quit, right? So clear, the menu entry is 1. We want it as first one, right? For quit, I'm making it as 0. For draw, it is 2, right? So which has a sub menu which is scan fill polygon, and I'm attaching the right button to this particular menu, right? So glut attach menu, glut underscore right underscore button, right? So once you have done this create menu, then you are calling your GL clear color, right? So initially it is black, right? So because on the black background, I'm getting my menu, right? So GL clear color 0 0.0, 0 0.0, 0 0.2. Then you are calling your display function. So this is your callback function, glut display func of display, right? So this display function will call my display function. So what my display function is doing, if value is equal to 1, it will do post redisplay. If at all value is equal to 2, that means I have to create my polygon. So once I am drawing my polygon, I will call my scan fill function. So this scan fill function will in turn call the edge detect function in order to detect the intersecting points of every scan line. Then which further will be calling my draw pixel function in order to draw the pixels between the color the pixels on the scan line, right? So then my initialization function will initialize your projection, which is your orthogonal projection. Then glut main loop, right? So if I want the output to remain on the screen, right? So I have to call a function which is called as glut main loop, right? So return function you are using here, because I have taken here at it as int main, right? So exit underscore success, right? So exit, if you want to display failure status, right? So that is exit underscore failure. This is simply like how we are using return function in our in our C programming, where it is return 0 is failure, return 1 is success. The same way return exit underscore success means success will be returned to the as a result of the main function. If I want to return failure, I can also give it as return exit underscore failure, right? So since here successfully we are able to display the function, right? So semantically we have to write it as return exit underscore success. So this is the output of your program, right? So as soon as you click your output, you will get your menu, which is clear, draw and quit. It has 3 options. Then if you click on a draw, you will get it as scan fill, right? So this entire menu is attached to the right button of your mouse, right? So you have to click the right button, then you will get your clear, draw and quit. Again on further draw, you have your menu option, which is scan fill polygon. The moment you click on this scan fill polygon, right, so your entire polygon you will get, right, so which is defined by your points. So whatever points you want, you can give, right, so based on those points it will calculate the intersecting edges. And since you have given the delay, right, so you can see that line by line on the scan lines the color will be filled, right. So here we have taken the color as a red in the lab program. So if you want to change the color, you can change the color in your draw pixel function. So this program you can also check for different types of polygon. We know that the scan fill algorithm works for convex polygon, right. So if I change the shape of the polygon, we can know the difference between the concave and the convex polygon. So what is a convex polygon? It is a multi-angled shape, right, with straight edges in which all the angles are less than 180 degree. In a convex polygon, we have all the angles are less than 180 degree, whereas in concave polygon we have the angles which are at least one of the angle will be greater than 180 degree, right. So a line drawn through a convex polygon, it will intersect the sides of the polygon exactly twice, right. So a line drawn through any convex polygon, it will intersect the sides of the polygon, right. So this line and this line, right, so it is intersecting the sides of the polygon exactly twice. So if I come to concave polygon, a concave polygon, it is a multi-angled shape polygon with straight sides in which all the angles are greater than 180 degree, right. So if you see the angles of your concave polygon, right, so it will be greater than 180 degree. So that is why it is called as the reflex angle. A line drawn through a convex polygon, it will intersect the sides of the polygon exactly twice, right. So whereas concave polygons are the polygons for which at least one line segment joining any points in the interior, it does not lie completely within the figure, right. So you can see that they in which at least one line segment which is joining any 2 points, right. So if you take any line segment which is joining any 2 points in the interior, it does not lie, right. So it is not completely inside the figure, right. So such type of polygon we call it as the concave polygon. So if at all I take an example of a concave polygon, right, so just to change the coordinates as x1 y1 as 100 x2 is y2 as 50 200, x3 y3 as 150 150, x4 y4 as 250 200, and add one more point 200 comma 500. So this is how your polygon will look like, right. So but since scanline fill algorithm, it works only for convex polygons, hence the sides which are making angle as 180 degree are ignored till the polygon becomes convex, and then it is filled with the pixels, right. So even though you have your concave polygon like this, but the output what you get will be convex polygon, right. So this entire polygon will be taken and your color will be filled, right. So because the concave scanline algorithm, it does not work for concave polygon, it will work only for the convex polygon, right. So those all the sides which make the angle 180 degree, they'll be ignored, right. So till the polygon becomes convex, and then the pixels are filled with the corresponding color. Thank you.